Here we're going to analyze the situation where there are two blocks hanging above and below each other, the top block being attached to a ceiling. And we want to figure out what is the tension in the top cable, what's the tension in the cable between them, and also at the end, if we were to pull on the bottom block slowly, which cable would break first. So I just want to name a couple things really quick. Let's call this T1, and we'll call this cable down here T2. And because we have two objects in this situation, we're going to have to draw two free body diagrams and write two sets of equations, and we should be able to figure this out. So first, let's draw free body diagrams. For the top block, we have what I called T1 pointing up, and we have the weight of block 2, or weight of block A, so I'll call it FGA, pointing down, and we also have the cable T2 pointing down as well, because both cables are acting on block 1 and the Earth is through gravity. For our red block, block B, we have gravity acting on it. And we also have the cable above it, which I call T2. That is pulling up. That's the way cables work. And that is it. The top cable is not acting on the bottom block. It is just the only thing acting on the bottom block is the Earth through gravity and the cable that's attached to it, which we call T2. And nothing's going on in the X direction, so we usually have things in the Y direction. And I'm going to quickly figure out the two weights. So I know the weight of B is going to be 4 times 10, which is 40 for on Earth. And for the top one, it's going to be 8 times 10, which is 80. Again, being on Earth. So now let's write a couple Newton's law equations. So sum of the forces on the top block, block A, is going to be, now I'm going to use up as positive. So we're going to get T1 minus the weight of block A minus T2, and that equals the mass of block A times the acceleration of our system in the Y direction. And let's do the same thing for the bottom block. Sum of the forces on B is going to be T2 is acting in the positive direction minus the weight of block B, and that's going to equal the mass of B times the acceleration of our system. Now, these are just hanging there. There's no acceleration. They're not changing what they're doing, so both of these are going to be 0. And I'm going to start with the red equation, with block B. And I should be able to find one of the tensions because I get tension 2. It's holding up block B. That's going to be equal to the weight of block B, which we already said was 40 newtons. So we have T2. Now I can just use that in my other equation and say that tension 1 minus the weight of block A, which is 80 newtons, minus tension 2, which is 40. That equals 0. So tension 1 has to equal 120 newtons. We got tension 1. So there are two tensions. The only last thing is it says if we were to pull on the bottom block slowly, which string would break? Well, assuming they're identical types of strings, they have the same strength, failure force that they can withhold. As I pull on the bottom block, we can kind of see that the top tension, if we look at this equation here, is really holding up the bottom block, is applying tension 2, and also it has to apply enough force to hold up the top block, so the top string is always going to be the one that breaks first. If you pull it slowly, if you pull it fast, that's a slightly different question. But another way to think about this is that when you have objects like this hanging, cables are always holding, as long as they're not accelerating, cables are holding up whatever is below them. So cable 1 here is holding up both masses, whereas cable 2 only has to hold up mass B because that's the only one that's below it.